Okay, so now let's look at a real quadratic equation. And a real quadratic equation is given to you right here. Okay, and here is, let me write the general form of the quadratic equation. Now, the quadratic equation is normally written as ax squared plus bx plus c. And we will replace these letters a, b, and c with real numbers. So here's an example of two different types of quadratic equations and what this really means for us. So here is a quadratic equation of 2x squared plus 4x plus 1. Now what I want to talk about is the leading coefficient, the first coefficient, the one that's in front of your x squared. So as I'm looking at that, I see that this is a positive 2. It's a positive a. In that event that you see this as a positive number, you know it's going to open upwards. So positives kind of make like a smile, if you will, right? And they open upwards. Okay? And that is basically what that means. Now, if you wanted to get super technical, and I feel like getting super technical here, we call that concavity or concave. And if you learn in science, it's kind of like a curve. So if I say, what's the concavity, or how, what, you know, what it, like, does it concave up or concave down? You'd say that it is curved or concave up. But if you say the words open up and open down, that's fine. But if you want to get super mathy and earn some, you know, cool math points, concave up would be the best term to say that. Let's also point out other things. Let's find the vertex. So here's your vertex. And I'm just going to create an arrow right. Here's your vertex. Let's get good at labeling this. So it's going to be, in the case of a positive a, your vertex is going to be the one point that is the lowest point on this graph. So if I'm looking at this vertex and I wanted to write the coordinate of the vertex, it's just where is that point? And this would be at -1, -1. Remember, you need parentheses around your ordered pair so that I know that you're talking about a point. And that's basically what a positive a does if that first term is positive. Here's an example of a negative a. So it's a similar equation, right? It does follow the ax squared plus bx plus c, except, you know, there's some subtraction. These can change between, you know, subtractions and additions. That's fine. But what I'm really worried about, or not worried about, but what I'm really focused on right now is this -2. This is negative, so what that means is that it's going to open downwards. Now, every parabola will look unique in its own way, but as long as this first term is negative, they're going to all be kind of curving downwards like this. And so it would be concave down, or it opens down. And let's find the vertex on this one as well. So when it's going to be curving down or concave down, your vertex will be all the way at the top. And this is going to be your vertex. Right? That's going to be your vertex. And we can actually write the coordinate for that vertex. So if I said, well, what's the coordinate of the vertex? You would say it would be -2, 3.